Welcome to my FPGA demo of the game that I made called Mimic. As the name suggests, the goal of this game is to reconstruct or mimic an input that the computer gives you. To start the game, we click the middle button. This enters the computer state to where the computer asks us to input that pattern that we just saw. The lights countdown indicate how long we have to see the pattern, and once all the lights turn off, we are in the next state where the user has to input that pattern back in order to receive a score at the end. Once we're in this state, we can traverse through all of the LED segments using our left, right, up, and down keys. The left two segments indicate the position that we're currently at. As you can see, we cannot go to the right two segments. However, when we click the middle button, we will flip the state of the current segment we're on, constructing a pattern on the right two segments. So if we were to construct that pattern that we just saw, which, if I recall, looks something like this. I believe this was the pattern that the computer gave us. Once we have this pattern, we can flip the bottom left switch to submit this. And then if it was correct, which it was in this case, we receive our score in seconds of how many seconds it took for us to construct that correct pattern. In this case, that would be 71 seconds. If we click the middle button again, we're back to the idle state and we can start the game again. Once that countdown ends, let's see what happens if we input an incorrect pattern. So let's just say maybe we thought that the pattern was just this. If we input this incorrect pattern, we'll receive a score of 999, indicating that the pattern that we inputted was not correct. It is only conditional upon inputting a correct pattern that will receive the time in seconds it took to input that pattern. And in this case, a lower score is better. In this game, we have four main states. We have this idle state. We have the computer state, where the computer gives the user the pattern to input. We have the user input state with the traversal. And finally, we have upon submission, we have the score state. These are the four overarching states. For example, within the user state, however, we have a nested FSM structure where each location of the 14 LEDs is actually its own state, where our four input buttons can traverse between. I have also made sure that each state is traversable through our grid. That way we can input any pattern that the computer gives us. Each time we start a new game, we pick one of 7 patterns using a 3-bit LFSR. That LFSR randomly picks between any 7 patterns, of course, with missing one. So any of these 7 patterns that we have available, and it'll choose one at random, and that will be the one that the user is tasked with inputting that round. The LFSR is set on a clock that is a lot faster than the actual game clock, making sure that chances are it will be quite random, depending on it, and it's not dependent exactly on the time that the user clicks the button, as long as the user does not click it instantaneously. With that is my game. I hope you have enjoyed. Thank you.